Welcome to our presentation. My name is Fernando Carou, and I'm with the City of Toronto. It is our pleasure to be hosting this year's IDA conference in Toronto. So this is actually a graph of the city's greenhouse emissions. As you can tell from the pie chart, similar to any urban jurisdiction, more than 50% of our emissions come, in fact, from buildings, with the balance of the bulk of the emissions from transportation. And then we also have a small amount of emissions that come from solid waste. Now, the bar chart to the right shows our emission reduction trend. And we're on track to exceed our 30% emission goal by 2020. As you can tell, also, Toronto actually is a jurisdiction with a cold climate, cold winters actually, and hot summers. So we tend to have high energy intensity, so obviously the name of the game here actually is to phase out the use of fossil fuels in buildings and transportation in order to reduce our emissions and reach our targets. Next slide. So the City of Toronto's climate action policy called Transform-TO was actually adopted by Council unanimously, and our main goal is to get to net zero emissions by 2040. So we basically have 18 years to reduce all of our emissions, both from the city, corporations, or the government itself, but also from the community at large. It's probably worthwhile to mention that the city corporation itself, it's only 5% of emissions, and the citywide actually is the balance, the 95%. But the city plays a role in reducing emissions within our facilities and our fleets, and at the same time with policies to affect the emission reduction citywide. Next slide. So we have a facility transformation plan to get to net zero emissions. As I said before, actually, a lot of our facilities actually have high energy use, and the one that we're going to talk about today actually is no exception. The key source of emissions, as discussed, actually is natural gas. So this is an example, actually, of facility electrification to reduce, the reliance on natural gas and essentially reduce emissions. And now Rick and Antoine actually will speak to the project.
Hi, my name is Rick Wu. I'm the project manager from City of Toronto. I'm the lead for this deep energy retrofit project at the city's EMS headquarters, and utilizing the integrated design and constructions model with an ecosystem. Next.
Thanks, Rick. And my name is Antoine, Courchesne-Tardif, project director at Ecosystem.
So here's some background information about the buildings. The original building is constructed in 1979. Throughout the years, other buildings are added to the site as an extension, and the last major renovation happens in 1992. The Toronto paramedics, fire, and police are the clients in the buildings. The buildings include office, call center, data center, garage, and warehouse for the supplies for paramedics. The total floor space is about 177,000 square feet. The table in the slides summarize the 2019 energy consumptions and GHG emission. The site consumed a combined of 4 million equivalent kilowatt hour between electricity and natural gas, and generates 714 tons of GHG emission. Next. The goal of the project is to achieve the Transform-TO target, which is an energy reduction over 40% and net zero GHG emission. Maximize the on-site renewable energy generations is also part of the scope. The project need to achieve a payback within 20 years. And the last goal, which is also how this project is all started, is to achieve a state of good repair, or SOGL, for the site. The chiller and the cooling tower on site have reached its service life. Instead of replacing like to like, we want to see if there's any opportunity to install heating and cooling equipment instead of just the cooling.
Yeah, interesting note about the SOGR here. It's always we always try to leverage SOGR to reach the other objectives. In this case, as Rick just mentioned, replacing the main chiller of the facility was an opportunity to choose a new unit that has higher condensing temperatures to unlock heat recovery potential.
The project takes a holistic approach, which investigate all the system and energy consumption equipments in the buildings, and utilizing an integrated design and construction service company. The project is funded by a city's Sustainable Energy Plan Financing, or SEPF, which requires a payback of 20 years. During the procurement process, we have included all our prescriptions, such as GHG energy reduction target, a payback requirement, chiller and cooling tower renewal, and also solar PV generations requirement. We included an extensive training program in the project for the operation staff so they can operate the building with the new type of heating and cooling system. And finally, we have included a 2-year monitoring period to ensure the retrofit is performed as designed. Next. Here's a quick solutions highlight. Um, the heating solutions for the project, we started with the lowest GHG heating source, and then we injected the heat to the load as the loads increase. Starting from heat recovery, then ground source heat pump, air source heat pump, and finally, if we have to, we will use the natural gas boiler to meet the heating requirement.
The design process here that we followed was basically to prioritize, as Rick mentioned, low GHG energy sources, but also the ones that are the most cost effective, which is often the internal heat recovery in the end. So waste heat from either internal zones or data centers, UPS rooms, all of that. So this is what was implemented first, and then higher payback. Renewable energy sources such as ground source and air source heat pumps were added to the design, leaving only a small portion of energy to be filled by natural gas boilers during peak periods. Some notes on the implementation considerations. So as Rick mentioned, this is a facility operating 24/7, hosting emergency services or paramedics, fire, and police. Uh, of course, lots of coordination was required during construction. It takes a bit more time to work into such an environment. And sometimes things don't go as planned and we need to replan some portions of work. But I think the main takeaway is to note that if it can be done, like a deep retrofit project can be done in such an environment, it can be done in almost all buildings in the city. An example of that, yeah, we're working in a tight urban space. So the place to do the geo exchange system was not very large. So in the end, we ended up using a different technology that enabled to drill deeper boreholes. So we had less boreholes than would have normally been required to reach the output. But we by drilling deeper, we could actually get the capacity that was needed by the design, and then complement with high temperature air source heat pumps. Back to you, Rick.
Yeah, thank you. So here is the overall outcomes of the project. The project cost is total around 6.1 million, which include $1 million of SOGL projects and also a larger, higher capacity solar PV system. And on top of that is the COVID-19 premium with all the price increase during these difficult times. With this, we achieve a 55% reduction in energy consumption and 65% of reduction in GHG emission. Next. Here is the breakdown of individual reduction. It is noticed that the heat recovery, ground source heat pump, air source heat pump, combined with the control optimization, achieve majority of the GHG and energy reduction. These savings can only be achieved when we procure or proceed with the project as a holistic approach instead of individual item throughout the SOGL system. Next. So we can briefly talk about the lesson learned here. This is the city first time to use a integrated design and construction service company to look into a deep energy retrofit project. We noticed that this procurement is not typical in the city design and tenders framework. So a lot of work has been put in place to set up the right format to procure this service. And one thing we noticed that is by doing this bundling all the projects as a holistic approach, we achieve a significant savings in both GHG and energy reduction. By also, one benefit about the integrated design and construction is to reduction in terms of change management, like change order, compared to typical design and tender format. These save a lot of times and effort, and the project can run a lot smoother. I think that's all I can say, Pierre. And Antoine, if you have anything to add.
Well, again, the coordination effort during construction and actually all the way through the design and construction process is really key to success for this type of retrofit project.
Thank you.
Thank you.